The blue-footed booby is a very peculiar bird that stands out with their unique blue feet. They are skilled hunters in both the air and the sea, to the point where they can catch flying fish while they are in the air. However, they are very clumsy on land. In fact, the word booby comes from the Spanish word bobo, which means stupid fellow. These tropical seabirds have bright blue webbed feet, brown and white streaked heads, blue and gray facial skin, and a white body. The bird itself is about 1 meter long, similar in size to a goose. The blue-footed booby lives on the beaches of the Galapagos Islands. They can also be found on several other islands off the coasts of tropical America, Mexico, and the coast of California. The life cycle of the blue-footed booby starts with a female bird laying eggs. These eggs will hatch in about 45 days. In the meantime, the parents will stand on top of the eggs in order to keep them warm. The newly born chicks will then take regurgitated food from their parents. If there is a shortage of food, then only the largest bird will be fed, while the others will be sacrificed. After about 2 months, the chicks will leave their parents. The lifespan of the blue-footed booby is generally around
17
years. The diet of the blue-footed booby revolves around fish. In Peru, the most important species for the boobies are the Peruvian anchovy, and in the Galapagos Islands, their diet is centered around sardines, more specifically, the Sardinops sagax. The booby is a secondary consumer as it feeds on small fish. The fish are primary consumers that feed off of zooplankton, and the zooplankton is an autotroph that produces energy from sunlight. The booby only has one natural predator, the Galapagos hawk. One decomposer in the food web is the common earthworm. Every few years, a huge storm called an El Niño hits the Galapagos Islands. It causes a rise in temperature and a shift in ocean currents. Because of this, many of the booby's food sources are reduced in population. Likewise, the booby must leave its natural habitat to find food. The booby is facing a huge new threat recently: ocean acidification. Ocean acidification is when the carbon dioxide that should be in the atmosphere is taken into the oceans, causing them to become more acidic. It is estimated by the IPCC that by 2100, the average pH of the world's oceans will drop by 0.14 to 0.35 units. Ocean acidification is making the conditions of the habitat reflect those of an El Niño, causing a great deal of harm to the booby. Ocean acidification is not actually causing El Niños. However, it is making the environment they live in have El Niño-like conditions, such as temperature rise and current shifts. Ocean acidification is thought to play a large part in causing the conditions of their environment to become like those of an El Niño. This could affect the blue-footed booby by making it increasingly difficult to breed and produce offspring. Their food supplies are diminishing, so they will not be able to produce offspring as often. When lacking food, the birds only feed their biggest bird, meaning that the population is going to be halved in size. This could also affect their habitats, such as the islands where they are breeding. For example, there are 34 sites around the Galapagos Islands where blue-footed boobies are breeding in nest. So far, 5 of these have been abandoned, with all nestlings in those areas dying. It is possible that more and more of these areas will become deserted.
Our amazing solution is hydrogen fuel cells.
It's great. Here's how it works. Alright, so hydrogen fuel cells, you got 5 parts, right? Now these two are just bipolar plates. Then you got your anode, your cathode, and then you got your electrolyte. So then you got hydrogen. You got hydrogen gas, and it'll go through. But then a catalyst is added. Catalyst that goes through, and now you'll have protons and electrons. Now the protons, they'll keep going through, but then the electrons, they can't just keep going through, so they'll go around. And this stream of electrons here that go directly to the cathode, that's your electricity. There you got electricity. Now, hydrogen power. This stuff's amazing, guys. All right, it's like hydrogen. Everything about it is great. Hydrogen is the most abundant element in the world. It's the smallest, so you could always make more and more of it. 75% of the universe is hydrogen. Like, it's great. We'll never run out. And plus, even if we can't find a lot of hydrogen on Earth, you can make it with any other primary energy source. So using gasoline or methane, you can make hydrogen. And hydrogen, it's also really easy to ignite. So you don't need a lot of ignition energy if, say, you're using an internal combustion engine. But, that's not too important for a fuel cell. But still, it's great, right? Now, hydrogen, it also has really high
Diffusivity.
hydrogen also diffuses really well. So say we're transporting a bunch of hydrogen, and there's a gas leak. Well, it will dissipate really fast and it won't have that big of an impact on the atmosphere. So it's a lot friendlier for the Earth. Plus, this hydrogen fuel system, the only emission that it makes is water vapor. Water vapor doesn't do squat to the Earth. That's the water cycle. It's already there. It's not going to do anything. It's great, guys.
Okay, calm down. There are some bad sides to hydrogen gas too, Mainly, it has a low energy density, so you need a lot of it to have the same amount of energy as other energy sources. The low ignition energy makes it a little unsafe to use. Also, it is pretty expensive. The biggest problem, though, is that it isn't found anywhere naturally, and the fuel needs to be manufactured. Sure methods exist, such as steam reformation using methane and gasification using coal, but they produce a good amount of CO2 and require the use of non-renewable resources.
What about electrolysis, man?
Well, electrolysis is good since it is a zero emission, but it requires electricity and the emissions of this depend on the source of electricity. You could use solar power, but those have shown large amounts of inefficiency. Using electrolysis can have an efficiency of up to 90%, but when taking into account the solar energy needed to produce the electricity required, the plant efficiency could drop to about 10%.
Okay, well, the problems you presented aren't actually that bad. Like the storage of hydrogen, there are lots of ways to store them. Like if you use metal hydrides, you can store lots of it, and it's very efficient, actually. And it's very safe to use that as a storage method. So that eliminates two of your problems there. I mean, it's a little expensive, but do what you gotta do. And then the biggest problem that you said, making hydrogen fuel, that's being solved more and more each day. They just came out with this new system where they use biomass to create hydrogen fuel. They can use xylose, which is the second most prominent sugar in the world, or cornstalk, so the wasted parts of the corn plant. So now it's just recycling, and you're using more renewable fuels. It's incredibly efficient, and it uses enzymes. So it's at low heat, so there's no danger from ignition energy, since you don't need to burn anything. And you do get CO2 emissions from this process, but you get about 2 moles of hydrogen fuel for every 1 mole of CO2, opposed to gasoline, where it's about 1 mole of gasoline for 8 moles of CO2. So it is phenomenally better. Plus, there is the hydrogen system. I know you talked about the high solar plant in Saudi Arabia, but solar panels are getting better and better each day. In fact, recently, they just created a new system where solar panels use heat and light to form electricity, making it a lot more efficient and just producing more energy. So making the hydrogen fuel isn't as much of a problem anymore. So hydrogen is still amazing, man. Invest today!
Wow, I'm so glad that this ocean acidification has decreased and the amount of fish has increased again. Now we can party. Like blue-footed buoys are supposed to. Yeah, blue-footed booby party. Woo! Look at all of us. There's a bunch of us instead of just one. Thanks, hydrogen. You're great. I really appreciate it.
Diffusivity. 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 Diffusivity.